Hello, I welcome you all to this wonderful lesson where we are going to look at this question, which is falling under concentration and the rate of reactions. So we are given this first question here, which is saying define concentration. What is concentration? So before we go any further, we need to understand the formula that is used when we want to calculate the concentration. We get to use the formula where we say concentration is equal to number of moles over volume. So once you know this formula, then it is very easy for you to define what concentration is. So what you are going to do is that concentration is, so the definition for concentration is the amount, you say this is the amount of what? Amount of solutes. So you know that amount of solutes, you are talking about the moles there. Amount of solutes dissolved. Have you seen dissolved? So we get to dissolve this. Dissolved in a, so I'll say dissolved in a unit volume, in a unit volume of the solution. This is the definition for concentration. Just looking at this particular formula where we say concentration is the amount of solutes dissolved in a unit volume of the solution. This is the definition that you need to understand. So just like that, you define what concentration is. Then we move to this other question here that is saying calculate the concentration of a solution made by dissolving 60 grams of sodium hydroxide pellets in 300 centimeters cubed of water. So now what we are given is the volume. We are given the volume. Volume is equal to what? 300 centimeters cubed. Are we going to use this volume? No. We need to change to what? Decimeters cubed. So we need to change to decimeters cubed. So what you're going to do, you divide by 1,000. So when you divide by 1,000, you're going to get 0.3 decimeters cubed like this. So the volume should be converted to decimeters cubed. This is what you're going to do. So this is what you've done. You know that the formula for concentration, so we are doing all these procedures because we understand that the formula for concentration I wrote at first is equal to number of moles over volume. So we've calculated the number of the volume which is here. Then we need now to go to the what? The number of moles. Number of moles is given by the formula where we say mass over what? Molar mass, which is equal to, we are given in the question, the mass we are given, it is what? 60 grams. So 60 grams over molar mass. Molar mass of what? Sodium hydroxide. This is sodium hydroxide. So how do you calculate the molar mass? You say this is 1 times 1. Here, this is 1 times 16. Here, that is 1 times 23. Have you seen? So 1 plus 16 plus 23. What answer are you going to get? You're going to get 40. So this is 40 grams per mole. This is the what? The molar mass. So this is how we calculate the molar mass. After calculating the molar mass, you put it there like that. What answer are you going to get whenever you divide there? What answer are you going to get? You know, this cancelled. 4 into 6, that is 1. So the answer there is 1.5 moles. You just use a calculator. You are going to get that answer. That is your answer that you are going to get. So have you seen the procedures that I've done? I'm just looking at this particular formula where I need to calculate the number of moles which I've calculated here, 1.5. So I'm going to put 1.5 there over, what is the volume? The volume is here. This is my volume, 0.3. So what is my final answer? when I calculate there. What answer am I going to get? I'm going to get what? 5. So 5, I'll say 5 moles per what? Dense meters cubed. This is my answer. The answer is 5 moles per dense meter cubed. Just like this. So you can do this. You can find the answer like that. If you want, this can also be written as 5 what? 5 molar, like this. It is just one and the same thing. Hope you've seen the way I've calculated this. This is how you need to calculate. These are things that you need to do. This is what you need to get and understand. So this is the answer. Then we move to this last question that is here. The last question here that is saying, what is the effect of increasing the concentration of the reactants? So for you to answer this particular question, you know that the concentration refers to the reactants in solution. When concentration is increased, meaning that the rate of reaction also increases. This is because the number of particles in the solution increases and collides with each other effectively. So the effect of increasing concentration of the reactants is that you also increase the what? The rate of a reaction, because the number of particles in the solution increases and collides with each other more effectively. On the other hand, we can say that when concentration is reduced, the rate of reaction also reduces, because the number of particles in the solution reduces and do not collide effectively. So hope you've seen how I've answered this particular question. This is what you're going to do. So here, the effect of this is that even the rate of reaction increases. The rate of reaction increases. This is what you need to know and understand. So these are the answers that we are supposed to get.